Hello. Today we will see the time response of a first order system using NI usb6009 by National Instruments. This is the USB6009. It has analog input, analog output as well as digital IOs. This side it is analog inputs and analog outputs. It is written over here, and same way you have this side digital IOs. Also you have a plus 5 volts and ground. When I am having the analog inputs, it has AI0 plus as well as minus, AI0 plus and AI0 minus. Now for a first order system, what we will do is we will take a simple RC circuit. I'll connect on my breadboard. R and C. So my RC circuit is ready. I'll give from the digital input over here, that is between R and ground, and I'll take the output across the capacitor, that is my output voltage across the capacitor. So I'm going to take the time response with respect to the transfer function Vo upon Vi. So I'll take a step response. To give a step response, I'll take digital IOs. So and I'll connect the USB6009 to my computer using a USB connector. Now I'll take my lab view programming. Open a new lab view, new VI, say Control T. So I have to have a data acquisition assistant, DAC assistant. So right click. Either we can take it from measurement IO, go to NI DAC Max and DAC assistant, or right click, go to Express, go to input and take the DAC assistant. Anyway we can do. Keep it over here. Now we have to say configure it for input or output, or analog input, analog output, or digital input, digital output, as the case may be. So now I have to acquire the signal. We have acquire signal, we have generate signal. So in this case I want to first acquire the signal across the capacitor. Say analog input. I have so many different types of input like voltage, temperature, position, frequency, velocity, force, etc. So I'll say voltage. I have to measure the voltage across the capacitor. So AI0. I can take any channel. As I said, I am having 8 input channels, 2 output, analog output channels and 12 digital IOs. So I'll say AI0. I am connecting with the AI0 now and say finish. So I can change the name. This is my output voltage. So it is giving the voltage. right click, rename. I'll say it as VO because it is my output voltage. And I'll give the values 10 to -10 in a differential mode, and the number of samples I'll say continuous sample 1k, and let us see with the rate 1k. Say OK. So it will ask you a question that you need to acquire data continuously, so would you like to keep it in a loop now? So I'll say yes, so that automatically while loop happens, I'll make it little bigger so that if at all I have to add something to that, I'll have enough space. So this is the while loop condition is here. So I'll take it over here and make it little bigger. Now I have to have a waveform chart over here, which I'll get. I'll keep the waveform chart over here and connect it to the data from my DAC assistant. Here also I'll say DAC assistant. I have connected to AI0. So now I have to give the input to my R. That I'll do step input. Step input means suddenly I have to give a voltage level. So I'll give from a digital IO. So I need to have one more DAC assistant. This time I'll take from measurement IO. You can take from anywhere, either from Express or measurement IO. So I have to generate the signal, analog output or digital. So I am using a digital output, say port 0. This is, I have selected port 0. We can select even port 1. Say finish. So one sample on demand. This is my actually speaking V in. So I'll rename it as V in or step input. Say OK. So I'll create a control over here so that I can give the input by right clicking, create control. Actually the control says that the data has to be in array, but right now I have only one value, either 0 or 5 for my step input. So first I'll keep it as 0 so that any charge in the capacitor also may go. Now I have to do the connections on my data acquisition, that is USB6009. So this is my breadboard and this is my USB. I'll do the connection, that is you have a AI0 plus and AI0 minus over here. This is AI0 minus and this is AI0 plus. This single strand wires I have screwed in using the screws here. So, and this is ground. So AI0 minus and ground will be to the ground point on my breadboard, and this is AI0 plus where I have to take the voltage across the capacitor, and this is my port 0 where I am giving the input, step input. So I'll connect it on the breadboard and show you. So the connections I have done. From here I have given the AI0 plus, this is AI0 minus, this is my port 0 and this is ground. So now when I run my lab view programming, it should work. So now it should discharge if any. So I'll again run with, I can clear the data by, now again I'll run with the 5 volt. So the charging happens almost to 5. This happens because my rate I have given may not be proper. When I simulated this DAC assistant, I have simply given 1K there. If I change, or if I change the value of RNC here, also it may work. We will do one more C. Right now I have connected 1 microfarad. I'll try with a 10 microfarad now. Again first I'll try with 0. Stop it. I'll give 5. No need of stopping, directly also I can run because it is in a while loop. So it is charging. So if you change the value of RNC, that time constant changes. Thank you.